Every single business, I don't care if it's a massive car company or the coffee shop on your corner, is in a constant fight with its costs. And understanding those costs, really understanding them, is the first step to understanding how any business actually works. So today, we're going to put on our entrepreneur hats and break down the real costs of production.
Okay, let's dive right into the super important idea. You see, an accountant and an economist can look at the very same business and see two completely different financial pictures. The accountant, well, they're focused on the explicit costs, the actual money that leaves the bank account. But the economist, they see that, plus all the hidden costs, the ones lurking just beneath the surface that really drive the decisions.
And this diagram just lays it out perfectly. Look on the left, accounting profit is pretty straightforward, right? It's your total revenue minus your explicit costs, the money you paid out. But now look at the economist's view on the right. Economic profit subtracts both the explicit costs and these implicit costs. So what are those? They're your opportunity costs, what you're giving up to run this business. And that is why economic profit is the true measure and why it's almost always smaller than what the accountant calculates.
All right, here's our game plan for today. We're going to start with profit and this idea of opportunity cost. Then we'll connect the factory floor to the balance sheet. After that, we'll meet the whole family of cost curves, figure out why they have their specific shapes, and then we'll wrap up by seeing what happens to costs in the long run. Let's get into it.
So, Section 1, Profit and Opportunity Cost. On the surface, the goal of any firm is simple: maximize profit. And profit is just total revenue minus total cost. But here's the million-dollar question an economist always asks. What do you actually include in total cost? Because it's way, way more than just the checks you write.
And this is the absolute key. An economist's view of cost includes every opportunity cost. Explicit costs are the easy ones, right? That's the money you pay for flour, rent, your employees' wages. But implicit costs, they're the invisible ones. Let's say Caroline, who owns a cookie factory, is also a brilliant computer programmer who could be making $100 an hour. Well, every single hour she spends making cookies, she's giving up that $100. That is a very real, though hidden, cost of doing business.
Okay, moving on to Section 2. This is where we get our hands dirty and move from the theory onto the factory floor. Because the physical act of making stuff has a direct mathematical link to a company's costs. It's not just abstract.
Now let's really dig into this table from Caroline's Cookie Factory. This is so important. With 0 workers, you get 0 cookies. Makes sense. When she hires her first worker, output jumps to 50 cookies an hour. So the marginal product, the extra output from that one worker, is 50. Now watch what happens with the second worker. Total output goes up from 50 to 90. So what's the increase? It's 40. That's the marginal product of the second worker. The third worker adds 30 more. The fourth adds 20. Do you see the pattern in that last column? 50, 40, 30, 20, 10. Every new worker adds a little bit less than the one before. It's not because they're bad workers. It's because they start getting in each other's way, sharing the same oven. This is called the law of diminishing marginal product, and it's a huge.
And here's what that data looks like as a picture. This graph is the production function. The slope of the curve, how steep it is, represents that marginal product we just talked about. See how it starts off pretty steep with the first worker and then just gets flatter and flatter and flatter? That flattening curve is the visual proof of diminishing marginal product.
Now check this out. This graph is the other side of the same coin. It's the total cost curve. It's basically a mirror image of the production function. Think it through. If each new worker you hire is less productive, that means it's costing you more and more in wages to produce each extra cookie. So, as the production function gets flatter, the total cost curve has to get steeper. They are two sides of the exact same story.
Okay, just saying total cost is frankly too simple for making real business decisions. You have to break it down. It's time for us to meet the entire family of cost curves, because each member of this family tells you something different and critically important. All right, let's meet the family. First up, you've got your fixed costs. Think of this as your overhead, the rent for your shop. You pay it whether you sell 1 coffee or 1,000. Then you have your variable costs. These are things like the milk and coffee beans. The more you sell, the more you spend. And from those two, we derive the 2 most important costs for decision-making. Average total cost, which tells you what's the cost of a typical unit, and marginal cost, which answers the crucial question, what will it cost me to make just 1 more? Let's really get into the numbers here for Conrad's Coffee Shop. Look at the row for 2 cups of coffee. The total cost is $3.80. So how do we get the average total cost, the ATC?
Simple division. You take the total cost, $3.80, and you divide it by the quantity, which is 2. That gives you $1.90 per cup. Now look down the ATC column. See how it falls, and then hits a low point of $1.30? Now let's look at marginal cost, MC. That's the change in total cost. So, to go from 1 cup to 2 cups, the total cost went from $3.30 to $3.80. The increase was 50 cents. So the marginal cost of making that second cup was 50 cents. Notice how MC is always going up? The real magic is how these last 2 columns relate to each other.
Okay, section 4. Let's take that table of numbers we just looked at and turn it into a picture. Because these curves aren't just random shapes. Their specific shapes tell a powerful story about a firm's production process. Honestly, understanding this one graph is a huge part of microeconomics.
And here it is. This is the main event. First, look at the blue average total cost curve. It's U-shaped. Why? Well, at first, your costs per unit fall because you're spreading your fixed costs, like rent, over more and more units. But eventually, diminishing returns kick in, your variable costs start to climb, and that pulls the average back up. Now look at the red marginal cost curve. It's always rising because of diminishing marginal product. But the single most important, most critical point on this entire graph is right there, the exact spot where the red MC curve crosses the blue AT curve at its absolute lowest point.
If that relationship seems a little tricky, here's a super simple way to think about it. Your average total cost is like your overall grade point average, your GPA. And your marginal cost is like the grade you get in the next class you take. Now think about it. If your next grade, your marginal grade, is lower than your GPA, it's going to pull your average down, right? But if your next grade is higher than your GPA, it's going to pull that average up. That's the exact same logic at work with these cost curves.
So that special point, that bottom of the U shape where the 2 curves cross, has a very important name, the efficient scale. This is the production sweet spot. It's the exact quantity of output where the firm is making stuff at the lowest possible cost per unit. For Conrad's coffee shop, that happened at 5 or 6 cups. If he produces less, he's not making the most of his fixed costs. If he produces more, he's getting inefficient.
All right, so everything we've talked about so far has assumed one big thing, that the size of the factory or the shop is fixed. That's what we call the short run. But in business, time changes everything. So let's zoom out and see what happens in the long run when a firm has time to grow. This graph shows the difference perfectly. Each of those steep U-shaped curves represents the short run, where you're stuck with a small, medium, or large factory. But in the long run, you have the flexibility to choose which factory size you want. The long-run average total cost curve, this flatter, wider U-shape here, is made up of the lowest points of all the possible short-run curves. It represents having total freedom to pick the perfect size for whatever amount you want to produce. The shape of that long-run curve tells us about the effects of getting bigger, or what we call scale. On the downward sloping part, you have economies of scale. Getting bigger actually makes you more efficient, usually because of specialization. But if a company gets too huge and bureaucratic, coordination becomes a nightmare and the curve starts to slope up. That's when you hit diseconomies of scale. Adam Smith described this beautifully all the way back in 1776 when talking about a pin factory. He realized that if you broke down the task of making a pin into tiny specialized jobs, one person just draws the wire, another just cuts it, a big factory could pump out a mind-boggling number of pins. That's specialization, and it is the fundamental engine behind economies of scale.
So let's just do a quick recap of our key terms. You have your fixed costs and your variable costs. Add them together, you get total cost. Divide total cost by quantity, you get your average total cost, or the cost per unit. And the most important one for making decisions, marginal cost. Remember that formula? It's the change in total costs divided by the change in quantity. That's the one that tells you whether to do one more.
And that really brings us to the core of it all. The next time you walk past a local business or see a report on a giant corporation, you can see beyond the surface. You can see the invisible story of their costs, the constant dance between average and marginal, the endless search for that efficient scale. So we'll leave you with this to chew on. If you were launching your own business tomorrow, in that critical first month, which cost would you be obsessed with? Your fixed costs you can't escape, your average cost, or your marginal cost? The answer really does determine everything.